everyone, it's Olivia here from Olivia's Online Tuition. Today I'm going to be talking you all through the June 2020 Higher EDEXCEL Paper 1. However, this paper was originally sat in November of 2020 because we were all a bit busy in lockdown in June, so it was moved to November. All the questions are timestamped in the description, so feel free to jump around. And yeah, let's get into it. Okay, so the first 5 terms of an arithmetic sequence are 1, 4, 7, 10, and 13. Write down an expression in terms of n for the nth term of this sequence. So first place you want to start is looking at the difference between each of these numbers. And you might notice difference is you're adding 3 to each number to get the next number in the sequence. And whatever number you get for this difference, that becomes the number in front of n in the nth term. That's going to be, in this case then, 3n. I then need to figure out, okay, how do I get from the 3n sequence to this sequence I have here? So the 3n sequence, what I mean by that is if I put numbers in where n is, how would I then get from that sequence to the one here? So if I put like the first term where n is 1 into 3n, I would get 3, right? 3 times 1, 3. If I put n is 2 in, which means the second term in the sequence, I would get 6. If I put n is 3 in for the third term, I would get 9, etc, etc. Then I need to figure out, okay, how do I get from 3 to 1, 6 to 4, 9 to 7? I need to take away 2. And that is how you do nth term. Question 2. Show that 2 1/3 times 3 3/4 is 8 3/4. Okay, so whenever you see mixed fractions on your paper, get rid of them. You can't work with mixed fractions. Well, I mean, technically you can, but you don't really want to. Just make it a nice blanket rule. Get rid of mixed fractions. So I would convert this to an improper fraction by timesing 2 and 3 to make 6, by adding 1 then on top to make 7. Bottom number is always the same. That's over 3. Multiplied by 3 times 4, 12, plus 3, 15 over 4. And then it's a show that question. So I don't need to put this into a improper fraction. I could. Actually, that would be more convenient too. But you could then work out this and put it back into a mixed number. Or you could convert this into an improper fraction too. Doesn't really matter. Let's convert it as well. So 8 times 4 is 32 plus 3. That's 35 over 4. Okie dokie then. Right, then all we need to do is multiply these together. So 7 times 15 and 3 times 4. 7 times 15, golly gosh, and that's 70 from 7 times 10, and then 7 times 5, that's 35. Add these together, that's 105 over 3 times 4, which is 12. And then I'm going to simplify this by dividing both of them by 3. 105 by 3. Let's figure out what that is. I don't know. 3 into 1 doesn't go. 3 into then 10 goes 3 times with 1 left over. 3 into 15 goes 5. 35 over 4. And would you look at that? It's the same. So 35 over 4 is equal to 8 3/4. And that would be 3 marks. Question 3. The diagram shows 4 graphs, graph A, graph B, graph C, and graph D. Each of the equations in the table is the equation of one of the graphs. Complete the table. Okie dokie. So I've got y is minus x cubed. I have got y is x cubed. I've got y is x squared. And this one down here that you can just about see is y equals 1 over x. Okay, and so the one that's a bit easier, in my opinion, is going to probably be this one. This one you should have seen before. It's a classic quadratic graph. The simplest one you do, you'll see it a couple of times in the syllabus. It's a quadratic graph. Quadratics always have at least an x squared in them. So this one must be graph D. Okay, and then if I know which graph is which, but if you didn't know which graph is which, now it's time for a bit of process of elimination. So one of these equations is considerably different to the others, as is one of the graphs considerably different to the others. So these ones are really similar, right? So these ones must be this one and this one, the x cubed and the minus x cubed. One of these one of these. But this one, graph A, is looking really different, and we're going to assume that this one is the y equals 1 over x, which it is, which is a reciprocal graph. And then for these two now, either you know what it looks like, or now you have kind of an educated guess. So this graph is in two negative quadrants, right? This one is a plus and a minus, this one's a plus and a minus. This one is in a positive quadrant and a negative quadrant, plus plus, minus minus. So because it's got two pluses, I'm going to bet that this one is this one, which it is. And this one is in negative quadrants. I'm going to prove that one is that one. So yeah, that's how I do it. Obviously, you could learn all these graphs, or we could do a bit of process of elimination, right? So there we go, that's that one. The diagram shows 4 triangles, triangle A, triangle B, triangle C, and triangle D. 2 of these triangles are congruent. Write down the letters of these 2 triangles. So, let me get rid of that. So congruent, what that means is these triangles are exactly the same in every way. They've got the same side lengths, they've got the same angles, the same in every way. What's not to be confused with is congruent and similar. A similar triangle will have all the same angles, but it'll be bigger or smaller, so it'll be enlarged, right? It'll have different side lengths, but same angles. Congruent triangles, same length, same angles. Similar, just same angles, different sides. So we're looking for 2 triangles that have the same side lengths and the same angles. Okay, so the first thing I'm going to do is, what I've noticed is these triangles have 2 angles in, but not a third. So what I'm going to do is figure out what each of these kind of missing angles are here. So I'll do this one first. So I'm going to do 180 angles in a triangle, take away 80, 100, take away 45. That's going to be 55. And then what I'm going to do then is work out this one. So I've got 180 minus 55 minus 45. I can see from that one's going to be 80, right? Feel free to do some long subtraction to check, but that's going to be 80. So these ones have the same angles and one of the same sides. Then next up, I'm going to call upon my rules of congruency. So these you need to know, these little these little kind of trios of letters that show you when something's congruent. So they are side, side, side. So if all 3 sides are the same, your triangles are congruent. Side, angle, side. So you've got 2 sides the same, 1 angle, congruent. Angle, side, angle. So 2 angles the same, 1 side the same, congruent. And then right angle, hypotenuse, side. So that's self-explanatory, also going to be the same. So this one, don't have any right angles, not going to be that one. But these ones we've just worked out. We've got 1 side the same, 10. We've also got 2 angles, well, all 3 angles the same actually, don't we? So we can know that that's angle, side, angle. So our 2 triangles that are the same are going to be A and D. And when you look at that, it's just the 2 triangles I went to first. Who'd have thought it? I don't actually know that. Just a lucky coincidence, I guess. Question 5. Sean pays £10 for 24 chocolate bars. He sells all 24 chocolate bars for 50 pence each. Work out Sean's percentage profits. Okay, so percentage profits, I know it's totally not like this in real life, I don't know, not a business student, but in GCSE maths, percentage profit is essentially just the same as percentage increase. That's all that means, percentage increase. Oop, if I could spell percentage, that'd be good, wouldn't it? Percentage. See, I can't talk and spell at the same time. One of my biggest traits. Well, negative traits, I should say. Percentage change or increase. Either or. A change is an increase. So the equation for that, if you recall, is change over original times 100. It means to work out the change in how much money he spent versus then got over the original amount of money that he spent in this case. So we need to work out how much money this man made. So we're going to do 50p times 24 because he's got 24 lots 50p, so I'm selling all these chocolate bars. And that is going to be like a half of 24, which is £12. So he's made £12. Okay, then the change will be what he spent on the chocolate bars, versus what he got. So that's a £2 change because he took back £12, but actually spent £10 of getting the chocolate in the first place. So the change, in this case, I'm going to write over here, is going to be £2 over the original, which was £10 that he spent, then times 100. So that's going to be 2 divided by 10, that's 0.2 times 100, which is then going to be 20%. Move that twice. 1, 2, 20%. Question 6. ADC is a triangle. AED and ABC are straight lines. EB is parallel to DC. Angle EBC is 148. That's that one there. Angle ADC is 63. That's that one there. Work out the size of angle EAB. You must give reasons for each stage of your working. 5 marks. It's going to be quite a hefty bit of working. Okay, so what I'm going to do first is I need to figure out exactly which angle that is, right? EAB, which one is that? Let's have a look. So the way you read these codes is you start at that end, so you start at E, then go on to the next letter, which is A, so I'm going to go that way, and then back down to the third letter, that way. So the angle is always going to be like on the middle one of this like letter trio. Just need to explain to which one, like which way it goes, essentially. So it's going to be that angle there. That's the one we are trying to find. Okie dokie then. So they've told us and shown us with these little arrows that these lines are parallel. So as soon as you see 2 lines that are parallel, your brain should be thinking about the different parallel angle rules, right? Your F angles, your Z angles, your C angles. Brain should be whirring with those, right? And I'm seeing a couple right away. I'm seeing these Fs going on here. You kind of see them? These like upside down F shapes, possibly. So I'm going to that in F angles, if I draw one down here, in these F angles here, the angles under the sticks, top stick, bottom stick, or like prongs of the F, they're the same. So in this F here, see if I can draw it out without looking a bit silly. Yeah, you see this one here? That's the top stick, so that's 63. So this one is also going to be 63. And then I need to give a reason for that. So I'm going to say that angle, so all this little symbol means, so angle BEA is equal to 63 degrees. Let me just get rid of this F that I've drawn so we've got some more space. So angle BEA is 63 as it is corresponding with angle CDE. So we called it an F angle just then, but you need to use the proper terminology for it when you're actually doing this written bit here. So F corresponding, the Z angles, which are like these ones, they're alternates, and the C angles, which are like those ones, they are co-interior, just so that you're aware. Okie dokie then, let's now reassess, see where we are now. Okay, so we've got this one now. This is kind of forming little angles on a triangle moment here, isn't it? We need to find, like, let's get a different colour. We need to find this angle here, right? And would you look at that, it's on a straight line with that 148. So what I can do then is do 180 minus 148 to figure out what this angle here is. So let's do that. 180, take away 148. 0, take 8, can't do, that's a 7, make that 1. 10, take 8 is 2. 7, take 4 is 3. And then 1, take 1 is nada. So then we got 32 degrees there. The reason for that is, so angle EBA is equal to 32 as angles on a straight line, add to 180 degrees. Cool. Okay, so that's that done. So now I've got a lovely triangle moment happening here. So if I add these up, take it from 180, I'm going to know my angle here. So I'm going to do, let me run out of space here, aren't I? Never have enough space in past papers. So I'm going to then do 63. Make sure you can still see this, so I don't think you will be able to. Let me shuffle it over here. Be able to see it up here. So 63 add 32, let's do that. That's a 5, and then that's a 9. Poking on them head. Oh well, living with them. And then we're going to do 180, take away 95. So that's then 7, 10, 5, 7 take 9, I can't do. 17 take 9, ugh, what is that, 8? And then nothing. So then that is then going to be 85. And that's your final answer. So then, one last bit of working. Angle EAB is equal to 85 as angles in a triangle. Add, sorry, just keep looking over here, make sure you can still see all the working. Add to, you can't see that, can you? Add to 180 degrees. Cool. And there we have it. And that is angles in parallel lines. Table shows information about the heights in centimetres of a group of Year 9 girls. So they've got the least height being 150, the median height, which is 165, and the greatest height, 170. This stem and leaf diagram shows information about the heights in centimetres of a group of 15 Year 9 boys. Okay. Compare the distribution of the heights of the girls with the distribution of the heights of the boys. Okay, so whenever we're talking about distribution, I'd always compare two things. An average, which luckily for us, they've given us the median, so let's work with that. So we're going to compare the medians, figure out who on average is taller. And then we're also going to compare the range, which is going to tell us how spread out the data is. So are all the boys very similarly heighted, or are they very varied, right? And who is more varied, boys or girls? That's what we're going to look at. So let's have a little look. See, so average, median. So the girls, the 165. The boys, let's work that out. So median is just the middle value, right down the middle. So there's 15 of them, so let's find the middle. I'm going to just add 1, make life easier. Divide it by 2, so 16 divided by 2 is 8. Round the 8th one along, which is 1, 2, 3, 4, 5, 6, 7. I feel that is actually the number 8. Have fun. So then that's going to be a height of 168, because these represents a 15 being a 1,5 here, which is in this case 150, 8 being the 8 at the end. So 168 median for the boys. So as you can see, the median is a little bit higher for the boys than it is for the girls. So the boys, which much like real life, tend to be a little bit taller in this study as in real life. So what I'm going to put is on average, the boys are taller than the girls. This is because the median for the boys, which is 168 centimeters, is greater than that of the girls. It's phrased slightly differently than I have. Maybe it's phrased better than I have, but that's why I put 165 centimeters. Okay. Next up then is the spread, the range. So range is just highest take lowest. So for the girls, nice laid out for us, we're going to do 170 take away 150. So the range for the girls is 20 centimeters. Then the boys, we're going to do 182 take away 158. Bit more awkward. 182 take away 158. Okay, let's do that. 12 take 8 is 4, 7 take 5, 2, 1 take 1 is 1. So the range there is 24 centimeters. We can kind of see that the boys' stage is a bit more spread out than the girls, right? The difference between the highest and lowest is a bit larger. So we've got 24 centimeters here. So the range for, what am I spelling? For the boys is greater than the girls, which means the boys' data is more spread out. There we are. Hopefully you can read that. I know my handwriting is not the neatest thing, not the neatest in the world. I was looking at my second monitor where it's written, I'm like, oh gosh, that looks horrible. But hopefully you can roughly read it. I did say it as I was writing it, so hopefully it's roughly understandable. There we are. That's that one. That's what I put. Okay, question 8. The diagram shows a prism placed on a horizontal floor. The prism has height 3 meters. The volume of the prism is 18 meters cubed. The pressure on the floor due to the prism is 75 newtons per meter squared. Work out the force exerted by the prism on the floor. Okie dokie then. Right. So well, we've been given an equation. What I would do first is figure out why on earth we've been given it, right? Let's put our numbers in, see what we're missing. So we've got pressure, that's 75 newtons per meter, is then equal to the force. That's what we're trying to find because that's what's in the question, divided by the area. Okay, so that's how we've been given this, the volume, right? Because we are still in need of an area value. So how are we going to do this? So the important thing to note is the volume of a prism is essentially just the area of one of the faces times through its length. So what they've done to get 18 is they've times the area of either that face or that face, then taken that and times it by 3. So to get back to the area, what we're going to do is just do this 18 divided by 3, and we're going to get 6 meters squared. Hopefully that makes sense. I'll go through it again very briefly just in case it doesn't. So we've got, so volume is essentially the area of one of the faces, take this one, it's on the floor, times through its length. That makes the volume. And if we want to go back to this, if we take out this element, right, this 3 meter element here, if we get rid of that, we'd get back here. So 18 divided by 3, 6 meters squared. And that is the area. Then I'm going to do 75 equals force divided by the area, which we now know is 6. Okay, so then to rearrange this, I want to get F on its own. So I'm going to get rid of this 6, times it up there, do 75 times 6. Okay, let's do that. 75 times 6, apply them together. 6 times 5, easy. 6 times 5, that's 30. 6 times 7, what awful one. 6 times 6 is 36, so 7 is probably 42. Add 3 is 45, 450 newtons. And there we have it. Question 9. Write these numbers in order of size. Starts with the smallest number. So I've got 6.72 times 10 to the 5, 67.2 times 10 to the minus 4, 672 times 10 to the 4, and 0.000672. Right, so one of these is in standard form. 2 of these are in like a sort of standard form, but this number is too big for standard form, right? Because standard form has to be between 1 and 10. And these numbers are too big. 672, too big. And this one's just an ordinary number. So I'm going to first off fix these and put that one into standard form and then compare them from there. So let's do that. So this one here, 67.2 times 10 to the minus 4. So I'm going to have to divide that one by 10 in order to get it to be standard form. I'll just get it to 6.72 times 10. So then if I'm dividing that by 10, I'm then going to have to kind of increase this by 1 in order to get it back to kind of where it was meant to be, right? So I'm going to have to do the opposite, and then I'm going to get minus 3. Okie dokie then. So that's that one done. And then I'm going to move on to this one, 672 times 10 to the 4. So what I'm going to be doing is dividing this one by 100 to get to 6.72. Because I'm dividing it by 100 in this case, I'm going to have to increase it by 2, which is then to 6. Then I've got this one here, so I'm going to put it into standard form. So I'm going to just write the number out again. So it's bit bigger. So we've got 1, 2, 3 zeros and a 6, 7, 2. And then, pretty standard form, I'm going to see how many times I have to jump to get from this point here to the middle of this, where I'm going to put it, right, which is 6.72. So I'm going to count 1, 2, 3, 4 places. So it's going to be 6.72 times 10 to the minus 4. Minus, because it says small number. Big numbers are for numbers that are positive. Small numbers, numbers that are negative. Okay, then I'm going to order them all. So my smallest number is going to be this one. It's got the biggest negative. So that's going to be 6.72 times 10 to the minus 4. Then I'm going to have this one here, which is the next negative, 6.72 times 10 to the minus 3. And then I'm going to have onto the bigger ones now, isn't it? So we've done that one. We have done that one. Yep. Then it's on to this one here. First one, 6.72 times 10 to the 5, next number up. And then this one here, 6.72 times 10 to the 6. Question finished. Given that A over B is equal to 2 over 5 and B over C is equal to 3 over 4, find A to B to C. Okay, so my first go-to thought here is, what do I know about the relationship between fractions and ratios? So I know that if a fraction equals a fraction, I can convert that to a ratio by some mystical mathematic means, right? So what I'm going to do here is I'm going to convert these into a ratio. So I've got then A to B, that's then going to be equal to 2 to 5, and then B to C, that's 3 to 4. That's something that always works. If you have ratios, you can convert them to fractions. Sometimes if it's a ratio equals a ratio. And then if you've got these fractions equals fractions, you can make them ratios too. So then, what I'm going to do from here is I can see I've got B in both places. So let's make these B's the same size. Right, so let's do that. So if I times this one by 3 and this one by 5, they're going to both become 15. So I'm going to do that as times all this one by 3. So I'm going to get that's 6 to 15. And this one by 5, that's then 15 to 20. So then I've got 6 to 15 to 20. If I then merge these two together, make them the same one, slap these two on the ends. And then if I divide, actually, I was going to say that by 3, but it's going to 3. So I think that's as simple as we can get it. How fun. 6 to 15 to 20. Find the value of the fourth root of 81 times 10 to the 8. Okay, so what I'm going to do there is I'm going to, because if you look down here, there's indices going on. Maybe that's a bit of a clue. Maybe I should put this into indices too. Let's do that. So I've got then 81 times 10 to the 8. And to the fourth root is to the power of a quarter. So fractions always means roots. Number goes from the bottom, number outside of the roots. Okay, and then I can use my rules of indices to know that power of power is power times power. This one's the power of 1, so I'm going to do 1 times a quarter, so then get 81 to the power of a quarter multiplied by 10 to the power of 8 times a quarter, which is then 10 to the power of 8 times a quarter, which is 2. So I'm then going to have 81 fourth rooted, which is, so I know that it's 3, but if we didn't know that it was 3, what would we do from here? So if they're asking you to fourth root something, that means that the something that you're going to get has been times by itself 4 times, right? So it can't be a big number, right? Because if it's a big number, then it'd be massive, right? Times itself by 4 times, end up huge. It's got to be something really small. I know it's not 2, because 2 to the power of 4, that's 2 times 2, 4 times 2, 8 times 2, 16. So I'm going to try 3 next. That'd be if I didn't know it was 3, that'd be my next logical step. Then I'm going to do 3 times 3, 9 times 3, 27, then 27 times 3, and 27 times 3, if it was double check, if you don't believe me, is 81. I know that that is going to be 3. And then times 10 to the 2, that's just 10 squared, so that's times 100. So that is going to give me 300. Okay, and then part B, Find the value of 64 to the power of minus a half. So again, we've got a fraction as a power, like we did up here. Fraction as a power means square roots, and then number in front means what goes in front. Technically, you shouldn't call it a square root unless it's like the 2 in front, but potato potato. Math is not a speaking exam, right? Call it what you want. So we're then gonna get 64 square rooted. Ignore the minus for now. Leave it alone. Put it outside, right? Leave the minus for now. And then we're going to do the square root, of 64, which is 8. And then that's with the power of minus 1. And negative power doesn't mean negative number, means reciprocal. Reciprocal means you're flipping the fraction, right? If it's already a fraction, you're going to flip it. If it's not already a fraction, you're going to make it 1 by putting 1 over it, because technically we are still flipping it, because if we made this a fraction as it was, be 8 over 1, which we're just then flipping to make 1 over 8, just like that. And then question part C, write 3 to the power of n over 9 to the power of n minus 1 as a power of 3. Ooh, doesn't look very nice to this, does it? What I'm noticing first is that's already a power of 3, convenience. This one, however, is not, but it can be because 9 is 3 squared. Let's do that first. Let's convert 9 to 3 squared. So I'm going to make 9 to n over 1. Just separate it from this for now, so it doesn't have to deal with all that fraction nonsense. And that's going to become 3 squared, all to the power of n minus 1, sorry. Okay, so I've just turned this 9, essentially, made it a 3 squared. But it's still, nothing's changed. It's just I've popped out this 9, put in a 3 squared in its place, but they're the same thing anyway. And then I'm going to do power of power, that's power times power. So these two are going to be multiplied to then get 3 to the power of 2n minus 2. So then if I put this back into the fraction, I've then got, make sure you can still see, 3 to the power of n all over 3 to the power of 2n minus 2. If I'm doing a power divided by a power, that's power take power, right? So I'm going to have 3 to the power of n, take away this bottom power down here, so take away 2n minus 2. And if I deal with these brackets, I'm going to again get 3 lots of n minus 2n, that's minus n. Then I'm going to get n minus minus 2, which is plus 2. I'm going to get 3 to the power of minus n plus 2, or the slightly superior, but not much better, to be honest. If you want, this won't be wrong if you left it at this. 3 to have 2 minus n. It looks a bit nicer, you know, less signs to deal with, but you won't be marked down if you didn't put it like this. But there we go. Perfect. Moving on. Okay, question 12. The table gives information about the weekly wages of 80 people. Right. Complete the cumulative frequency table. All right then, so cumulative frequency, so if you're accumulating something, like if you're accumulating something, you're getting it like over time, right? If you're accumulating wealth, then you're just getting wealth over a period of time, right? Same thing with cumulative frequencies. It's going to be each one kind of added to the next to eventually get, in your last box, you should get the total number of people, which should be 80. So first one, nothing to add to because there's only 5 people in total in the studies thus far. And then the next box, everyone thus far that earns less than 300 essentially, which is 10 plus 5, which is 15. I'm going to keep going, adding on the next one as I go. I'm going to tick them off so I don't forget them. So I know which ones I've done. So I'm going to then add this 20 on, which is then, what was that, 35, another 20, 55, 15, out of 5, 60 out of 10, 70, and another 10, 18. There we are. We've got the same number of people that we should have. Easy peasy. And then on the grid opposite pair. I guess you know that it's in the next page, hopefully. On the grid opposite, draw a cumulative frequency graph for your completed table. Right, where is this graph? Is it over here? I don't know. Let me see. Oh, would you look at that? There it is. Right. So, cumulative frequency graph. So when you're in cumulative frequency, you're looking to plot the edge of the range with the cumulative frequency. So you want edge of the range, which is this one here, with cumulative frequency. So let me go to the other page. We can draw it out now. Okay, so now I've got my table over here, which is what I had on the last slide, it's carried over with my grid for cumulative frequency, remember, plotting at the edge, oops, easy, plotting at the edge of the grid line with the cumulative frequency. So first one's going to be 255. So I'm going to go along to 250, which is there, and then up to 5, which is there. That's that one done. Tick off once I've done it. Then I'm going to 300 and then up to 15. There we are. And then 350 to 35. Which is there. And then I've got 455, which is there. And then I've got 450 and 70, which is up here. Get very close to the camera because I'm wearing my contact lenses, so I can't see very well, and the grid's making my eyes go funny. That's that one done, and then I've got 500 with 80, which is all the way up there. Okay, so the cumulative frequency, it should look something like an S. Not looking very S-shaped here, but normally that's how it goes. So I'm going to kind of roughly kind of try and plot that. So I'm going to, not off to a good start here, am I? So a bit of a tip for this. It's easy. It would be easy if you had it in person, like on a flat sheet in front of you. I do not. I have a graphics tablet and my computer screen. So with drawing curves, you want to try and hold your pen like right at the edge, like that, right at the end of it. And then you can do like big sweeping arches with like your wrist or with like your whole hand if you want to do it like that. It makes your drawing curves a bit easier, as I learned from some of my art students. Well, students that I have that study art. So whatever, it's a bit hard for me because I've got a graphics tablet which obviously you can't then. You just use the tip, use any part of the pen, you have to use it right at the edge. So it's going to look a bit wonky, but it should look something, oop, kind of missed it a little bit, but something like that. Cool. I'll get on a good one. Actually, let me grab that now. I'll grab a better one, and then I'll show you what it's meant to look like. Okay, so down here is Maths Genie's version of the graph. They've got the next question on here as well, like the next part of the question, which is why they've got these lines here. But as you can see, it's looking a lot smoother than mine, but the points are in the right place, just to, so that, you know, don't want you doubting me or anything. So let me get rid of that. Let's go see what that next part is. Let's have a little look-see. So Juan says 60% of this group of people have a weekly wage of £360 or less. Is Juan correct? You must share how you get your answer. Okay, 60% of this group of people have a weekly wage of £360 or less. I'm going to grab a picture of that and I'm going to take it with us. Let me put that there so we can see it. Okay then, so let's have a little look see. So let's first off, where is 360? Let's look at that. Whereabouts is it on here? Oh gosh, golly gosh, right. So if that's going up in 50s, that's what, 10 in 50s? So 10 spaces to get to 50 on here. So that must be going up in what? 5s? Yeah, sounds about right, doesn't it? 5, 10, 15, 20, 25. Yeah, that's right. Going up in 5s. So if we're running it to 360, that's 2 lines above 350, which is going to be about there, right? So let's go from there. I'm going to use a different colour pen so you can see the different parts of the question. So I'm going to go up from 350 on the second line, which is there. A little bit, oop. Okay, thank you. Up here like this on the second line, there we are. Then I'm going to go along from the second line, which is there. So it's from there. So yeah, that looks about right. So that is about, what is that, 36 people? Okay, 60% of this group, so 60%, let's find out how many people that actually is. So let's do 60% of total number of people, which was 80. So let's do 10%, that's 8, and then times that by 6. 60% is then 48. Okie dokie. So yeah, so if I'm 10%, then 6%, just times 10% by 6, 48. Now we've got that. One says 60% of this group of people have a weekly wage of £360 or less. We've worked out that currently 36 people have a weekly wage of that much or less, and not the 48 that he was claiming had that little money. So Juan is wrong. So no, he is incorrect, unfortunately. And there we are. Question 13. Liquid A and liquid B are mixed to make liquid C. Liquid A has a density of 70 kilograms per meter cubed. Liquid A has a mass of 1400 kilograms. Liquid B has a density of 280 kilograms per meter cubed. Liquid B has a volume of 30 meters cubed. Work out the density of liquid C. Right, so what I always do with stuff like this, we've been given so much information, right? Like, look at all this stuff here, all this nonsense, right? So much stuff. What I would do is we need to work out the density of C. Let's set that equation up, see what we need to find, then focus our efforts in on there. We know that density, that's rho, or D, if you want to be basic, is mass over volume, mass per unit volume. So we need to work out the mass of C and the volume of C. Okie dokie then. So how are we gonna do that? So mass of C, so A and B have been mixed, right? So we work out the mass of A, which we have, we work out the mass of B, add them together, that's gonna give us the mass of C, right? So that mass is gonna be 1400 plus whatever the mass of B is. So let's find that. So we have for B of the density, which is 280, is then equal to mass, which we're trying to find, divided by 30. Okay, which is the volume. It's mass of a volume. So then to find the mass of that, I'm going to do 280 times 30, just times that up there, because it's currently a divide, so I'm going to bring that up there. And then from that, I am going to get, let's work that out, so 3, whoop. Hello? Oh, there we are. So I'm going to do so I'm going to do 280 times 30. 30 times that's going to be a whole bunch of zeros, starting with another 0. So 3 times 0, nada. 3 times 8, 24. 3 times 2, 6, 7, 8. 8,400. There we are, 8,400. So I'm going to add that on. And that would be the mass of C. Then we work out the volume of C. So again, volume of A plus volume of B is going to be equal to volume of C, because they're mixing them together. Volume, just like the unit of like how much liquid you have, right? If I take the amount of liquid in one jug, add it to another jug, I'm going to get the volume of the third jug. Does that make sense? Roughly. So adding up the volume. So I know the volume of B, that's 30. Let's work out the volume of A. So density of 70 is equal to mass of 1400 divided by the volume. So I'm going to do a bit of a switcheroo, times that up there, which is 70V equals 1400, and then divide that down there, which is V is 1400 divided by 70. Get rid of them, got 140 divided by 7, which is going to be 14 to 7, that's 2, add a 0, 20. Then I've got 20 plus 30, I'll bring that back up here. Then let's figure this out. I'm going to get rid of some of this stuff so we've got a bit more space. Don't mind me while I rub out this. Gone. Okie dokie. I'm going to do 1400 plus 1800. It's going to be 9,800. Add on 20 plus 30, that is 50. Okay. Non-calculator paper, so I'm going to get rid of them and then do 980 divided by 5. So then I've got 980 over 5. So I'm going to just divide those. Might as well. Non-calculator. So 980 divided by 5. 5 into 9 goes once with 4 left over. 5 into 48. Well, 5 goes into 45 9 times with 45, so 3 left over. And then 5 into 30, 6 times. So 196. And there I have it. Question 14. Sally plays 2 games against Martin. In each game, Sally could win, draw, or lose. In each game they play, the probability that Sally will win against Martin is 0.3. Probability that Sally will draw against Martin is 0.1. Work out the probability that Sally will win exactly one of the 2 games against Martin. Right. Question 14. Sally plays 2 games against Martin. In each game, Sally could draw, win, or lose. In each game they play, the probability that Sally will win against Martin is 0.3. Probability that Sally will draw against Martin is 0.1. Work out the probability that Sally will win exactly one of the 2 games she played. Right, so what could Sally do? So Sally could win the first game. She could then lose the second game, right? She could win the first game and then draw the second game. She could lose the first game but win the second game. And then she could draw the second game or first game and win the second game. Those are her options, right? She could do more, but we want to know how exactly one. So we want only one of these to be wins. Does that make sense? So now it's time to work out probabilities of each of these options. So we've got win and lose. Probability that she will win against Martin, that's 0.3. Probability that she will draw against Martin is 0.1. So let's have a look at this. So what would probability she will draw? So drawing, that's going to be kind of whatever's left over. Actually, I've got 3 options: draw, win, lose. So we'll see whatever's left over. So these added together, that's 0.4. Take that from 1, which is like 100%, definitely probable. So take it from that, that's then 0.6 left over. So 0.3, and then, not draw, win, lose, sorry. Silly me, pardon me, lose. So losing is 0.6, and I'm going to times that 0.6, which is 0.18. Then I'm going to do win and draw. Probably going to win is 0.3, draw is 0.1, which is 0.03. This is the same as just dividing it by 10, essentially. And then we've got lose and win. So losing is 0.6, oopsie daisy, and then winning is 0.3, because we've already done this one, just opposite way around. That's also 0.18. And also, it's also the same the other way around. That's also going to be 0.03. Then what I'm going to do is add all these together, which is 0.18 plus 0.18 plus 0.03 plus 0.03. Add them together, 8, 16, 17, 18, 19, 20, 21, 22, 2, 3, 4. 0.42. Question 15. The straight line L1 has the equation y equals 3x minus 4. The straight line L2 is perpendicular to L1 and passes through the point 9, 5. Find an equation of line L2. Okie dokie then. So, key thing to note, perpendicular lines have negative reciprocal gradients. So what that means is they take the gradient of one line, make it negative, you flip it, and that's the gradient of the second line, the perpendicular line. So the gradient of the first line is this 3 here, because y is equal to mx plus c, where m, that's the gradients, and c, that is the y-intercepts. Okay, so the gradient of the first line is 3, so then I need to kind of make that the gradient of the perpendicular line. And to do that, I'm going to make it negative, minus 3, then flip it 1 over minus 3, or minus a third. So the gradient of L2 is going to be minus a third. Make it negative, flip it. Okay. And then straight line L2 perpendicular to L1, done that bit, and passes through the point 9, 5. So we then need to find, for the full line, the y-intercept, right? Y equals mx plus c. We've got m, we need c. So what I'm going to do is put in the gradient into here to start building up our equation. So we've got y is equal to minus a third x plus c. And then, if you've noticed, I've got 3 unknowns, y, c, x, and that is no good. Can't have 3 unknowns, can't do nothing with that. So I need to get rid of 2 of these, and I can get rid of y and x using this guy right here. I'm going to put that in there. So x is 9, y is 5, so 5 is equal to minus a third times 9 plus c. And then, if I move this over here, 5 equals minus a third times 9. That's just the same as doing 9 over 3, which is minus 3 plus C. So then C is 5 plus 3, 8. Then I've got, if I put all this information together, put that back in there, I will have y equals minus a third x plus 8. And there we have it. Okay, question 16. Shirley wants to find an estimate for the number of bees in her hive. On Monday, she captures 90 of the bees. She puts a mark on each bee and returns them to her hive. On Tuesday, she captures 120 of the bees. She finds that 20 of these have been marked. Work out an estimate for the total number of bees in her hive. Note the estimate in this case doesn't mean you can start rounding numbers up or down. It normally does, but not in this case, because we're kind of estimating. She's kind of doing like a bit of a guesstimate, right? Because she's marking bees and waiting for them to come back to her. So it's never going to be accurate, right? So that's why it's an estimate. So you can't be going rounding numbers willy-nilly. Okay then, so what I'm going to do then is, so she's currently marked, how many did she mark? 90 out of however many bees she has in her hive, right? However many. And that is going to be equal to the number that she's then recaught, have been marked, 20 out of the total that she's caught on that day, 120. So because we're saying that this 90 that we've caught, this 90 bees out of the first is kind of proportional in size to this new kind of catching that we've got. Does that make sense? So the spread will be the same roughly. So that'll help making it a bit easier. So let's go from here. So 90 over something is 20 over 120. So what I'm going to do from here is divide these two, get rid of them. So then I've got 90 over something, change to an x, make it more fancy, is then equal to a sixth. Okay, and then what I'm going to do is times that up there, divide that down there, 90 divided by a sixth, that's just the same as 90 times 6. All that means equals x, and 90 times 6, well 9 times 6 is 54, so I'm going to add an extra 0, 540. So, part B. Shirley assumes that none of the marks had rubbed off between Monday and Tuesday. If Shirley's assumption is wrong, explain what effect this would have had on your answer to part A. So, Shirley would have overestimated, focus on spelling, Olivia, overestimated the number of bees in her hive. The reason for that is, so she's collecting bees, right? She's collected some bees, and 20 out of the 120 that she's caught have been marked, right? Out of the 90 that she originally put in there. So if she's caught 120 bees and only 20 have been marked out of 90, that would suggest, wow, there's a lot of bees still out there, right? The other 70 that I've marked are still out there, and I've caught quite a lot of bees right now. So there must be loads and loads and loads of bees out there, right? But if that's actually wrong, and she should have had more bees in her sample that have been marked, then there would be less out there. So it seems like there's less in the hive. Does that make sense? There's going to be less in the hive because she's got more in her hand. So if she's got more in her hand, there's going to be less in the hive. Does that make sense? So she's overestimated, if that was the case, if they have rubbed off, she's overestimated the amount of bees in her hive because she has kind of more, she'll have less in her hand than she should. Does that make sense? If they're not in her hand, they must be in the hive. Does that make sense? Hopefully. Fingers crossed. If it doesn't, let me know in the comments. It's hard to explain this sort of stuff. So if it doesn't make sense, let me know in the comments, and I will try and explain further with bigger brain than I have today. Moving on. Okie dokie then. 17. Make F the subject of this formula. F is in more than one place. If you're rearranging or changing the formula, and F or whatever letter they have comes up in two places, you're gonna have to factorize eventually to turn those two letters into one letter. Right, so bear that in mind. But first things first, I've got a fraction. I don't want a fraction. Fractions are stinky. They're hard to deal with. So I'm going to get rid of that and move that up there. So I'm going to times all that up there. So we're going to do D times by F minus 4, which I'm timesing by all of it, timesing all of it up there. And that's then going to be equal to 3 lots of 1 minus F. Then I've got a bunch of brackets here. let's expand all those. So then I'm going to have df, or fd, the order doesn't really matter, minus 4d is then equaling to 3 minus 3f. Oop, that's not 3f, that's ff. 3f. Grand. Then I'm going to get all the f's on one side and everything else on the other side, because I want to try and get f's on their own. So let's bring them all together. Round up the family, right? So I'm going to add this 3f over there just to make the f's positive, then move that 4d over there, make them positive. Happy scenario all round. So then I'm going to get df plus 3f is equal to 3 plus 4d. And then this is the time for factorising. Do we see we've got f here, we've got f here, but we want one f. We can't add these because we've got d amounts of f plus 3 amounts of f. What's d? Who knows? Not me. So we don't know what we're going to add. We can't make this 1. We don't know what it is. So let's factorise it out instead. So I'm going to move that up here. So then we've got f lots of d plus 3. That's equal to 3 plus 4d. And then I'm going to get rid of that. Send it down there. Because currently these are being multiplied. So I'll just divide that down. I'm going to have f on its own. Ta-da! Would you look at that? Factorising saved the day. And there we have it. Moving on. Okay then, question 18. X is proportional to the square root of y, where y is greater than 0. Y is increased by 44%. Work out the percentage increase in x. So y has been increased by 44%. So I'm going to put like y is now like 1.44 of y, right? Because it increased by 44%, so that's now y. Then x is proportional to the square root of y. So x is proportional to the square root now of 1.44y. Does that make sense? And then, can we square root this? I wonder, is there anything that we can times by to get 1.44? And now I know that 12 squared, that's 144. So now I'm going to look at this. So I've got, that's 12 times 12. If I do 1.2 times 1.2, then I'm going to be making this 100 times smaller. Does that make sense? So I'm going to do 1, 2, make that 1.44. So if I square root this, I'm going to have 1.2. So then x is then equal to 1.2 lots of root y. Let's square root of this. I can take this out, left with root y. So then x is then proportional to 1.2 lots of root y. So x is going to be essentially 20% bigger for this one there. Does that make sense? Question 19. F and g are functions such that f of x is 12 over root x and g of x is 3 lots of 2x plus 1. Question A, or part A, find g of 5. So what they've done here, if you can kind of see, they've replaced x with a 5. So that is exactly what we're going to do. So I'm going to write out g of x, and every time I see an x, I'm going to put a 5 instead. So I'm going to do 3 lots of 2, and there's an x. I'm going to say instead, not times that by x, but times that by 5 instead, plus 1. This being a times and not an x. Okay, then I'm going to work out this bracket. So 3 lots of 2 times 5, that's 10, plus 1, that's 11. 3 times 11, 33. Okay, then part B. Find g of f of 9. So with this one, you want to kind of read functions backwards, going this way. So first thing we're going to do is put 9 into f. I could put 5 into g up here. I'm going to put 9 into this one. So f of 9, that is then 12 over root 9, which is just 12 over 3, which is 4. And then I'm going to carry that train along, and then put 4 into g. Okay, it's just carrying along the chain. Put 9 into f, and the answer to that, then into g, right? So then I'm going to put that into g, so I'm going to have 3 lots of 2 times 4, oops, daisy, plus 1, can't forget that. So then I'm going to have 3 lots of 2 times 12 is 8, plus 1 is 9, 3 times 9, 9, 18, 27. Grand. Then I'm going to do find g, inverse of g of 6, essentially. inverse g of 6. So in order to do this, we want to put we want to put 6 into the inverse of g. So for that, we need to find the inverse first. So to find the inverse, you want to kind of swap everything around. So what I normally do to do this is, instead of doing g of x, that's a bit more awkward, change it to y. We're used to y. We like y. Y is equal to 3 lots of 2x plus 1. And then I'm going to want to try and swap these over. So I need to swap them, get x as the subject. Then I do y is equaling 6x plus 3. Take away 3, y minus 3 equals 6x. Divide it by 6. Y minus 3 over 6 equals x. And there we have it. So then I just made y up. Y doesn't exist. So I'm going to put x back in where y is. Just swap them over a little bit. Then I'm going to get x minus 3 over 6. Then that is then g minus 1 of x. Ta-da! That's the inverse. Then what I'm going to do is just whack 6 in. 6 minus 3 over 6. That is just 3 over 6, which is 1/2. And that is functions. Ta-da! Okay, question 20. Oh, look at this. Weird question. Show that the square root of 180 minus 2 root 5 over 5 root 5 minus 5 can be written in the form of a plus 5 root 5 over b, where a and b are integers. Okie dokie then. So, let's put in a couple of things here. Is that this guy is too big. Don't like I said, that's too big. So let's get rid of that kind of bigness, essentially. So in order to get rid of surds that are too big, well, not all of them, but some of them, what we're going to want to do is try and find two surds that multiply to give 180, or two numbers that multiply to give 180, but one of them want it to be a square number to make life a bit easier. Then we can square root it, hey presto, because root a multiplied by root b equals root ab. So we're finding two numbers that multiply together is 180, so we can split it back up again. So let's have a think about what will do that. I'm thinking that 5 might, because there's a lot of 5s going on over here. We need to leave it in terms of 5, like root 5. Let's try 5. Let's see how many times 5 goes into 180. Let's see, I don't know that off the top of my head, so let's work it out. 5 into 10, or 5 into 1, sorry, don't go. 5 into 18, 3 times, with 15, 16, 17, 18, 30. 5 into 30, 6 times. That's root 36, and would you look at that? That is a square number. So let's write it out. So then we've got root 36 times root 5. That's root 180. And then I can root this, root 36. That's just 6. So 6 root 5 is equal to 180. Okay, let's put that back in there. Then I've got 6 root 5 minus 2 root 5 over 5 root 5 minus 5. So I know I'm going to need to deal with this eventually, because you can't have a surd bottom of a fraction. That is crazy talk. The math gods denied it, so you're not allowed to have that down there. So you need to move this eventually by rationalising the denominator. But first, I'm going to deal with these up here. 6 lots of root 5 minus 2 lots of root 5. That is 4 lots of root 5. Make life a bit easier. And then over 5 root 5 minus 5. Okay. Then I'm going to rationalise this. So there's 2 things on the bottom down here. 2 things. Which means you need to times it by those 2 things. 5 root 5 and 5. But you need to change the sign. And that's going to make your surds on the bottom cancel out. That's what we want. Over 5 root 5 plus 5 to make it just, this is just 1, right? So not really changing it, was kind of manipulating it, right? See, we're just a gaslighter, right? We're telling this guy that we're not changing him, but technically we kind of are. Cool. So now I've got this going on. I'm going to expand these brackets times top by the top, bottom by the bottom. So we're going to have 4 root 5 times 5 root 5 first off. So for that, I'm going to do 4 times root 5, which is just this, just kind of times the middle, and then times that by 5 times root 5. So with this, number goes with number, makes 20. Root 5 goes with root 5, makes root 25, and then that makes 5. Times that by 5, which is then 100. That's the bit. And then I've got one more, 4 root 5 times 5, that is plus, that I've got on top, I've got a 100 plus 20 root 5. Okay, then I've got the bottom. So then I've got 5 root 5 times 5 root 5. That is 5 times root 5 times 5 times root 5, which is 5 times 5, 25. Root 5 times root 5, root 25. And then that's 5. I've got 25 times 5, which is just 5 cubed, which is 125. That all makes sense. You just make 5. So it says 5 times 5 times 5. And then I've got then that one times that one. So 5 root 5 times 5, 25 root 5. So 5 root 5 times 5 is 25 root 5. Just that number times that number. And then I've got minus 5 times 5 root 5, which is minus 25 root 5. So that's going to go with that. Get rid of that. Then I've got minus 5 times 5, which is just 25. Or minus 25, I should say. Then look at the bottom now. We've got 125 from this first one. Take away 25. Okay, we then simplified that a little bit. We'll have 100 plus 20 root 5 over 100. Okay, but this is not the form it wants it in. It wants it in this form here. So what we need to do is split these up into 2 different fractions. One's going to make it just a number, one's going to cancel out. The other is going to stay as a fraction. So what I'm going to do first is do 100 over 100. That's just 1. And then plus 20 root 5 over 100. That cancels with that to make 5, right? Because 20 divided by 100, that's just a fifth. You can cancel that down, whittle it down until you get 1 and 5. So that makes 1 plus root 5 over 5. So A is 1 and B is 5. Ta-da! What a long question. Oh no, you can't even see it. Well, trust me, that's a 5 down there. This number here, just the number 5. So that's just, it's 1 plus root 5 over 5. There you go. Right. Okay, question 21. DEF is a triangle. P is the midpoint of FD. Okay. And then Q is the midpoint of DE. F to D is A, right? And F to E is B. Use a vector method to prove that PQ is parallel to FE. Right, so let's put these ones on first because they're given to us. Let's whack them on the diagram. Can't hurt, right? So F to D, that's that one there. So that's then A, and F to E, that's that one there. That's B. Okay then, right. So the thing I always say about vectors, to all the students I have, the thing I always say is vectors are the worst. I don't like them at all. It's the one math topic that I consistently don't like, right? All the other ones, they have their negatives, they have their perks to them, but vectors I think are really, really tough, okay? So vectors are really challenging all the time, consistently. They're always right at the end of the paper unless you got like a grade 5 one. They're not too bad. But the grade 9 ones are really consistently challenging. So if you can't do it, don't worry. Not many people in the country will be able to, so you will not be alone. Have a go at it, you know what? And if you really don't know where to go from here, just find random vectors. Go think, okay, can I find from F to P? Can I find from F to Q? Can I find from E to D? Can I find from E to P? Just do random ones. Just fill your last remaining 15 minutes of your exam with it. If you have time left over, obviously finish your paper first, then come back to it. But if you finished your paper and you have time left over, just go back, find random vectors, because chances are you have to scrape a couple of marks where you couldn't before. So that's my advice. But for those that are very academically able out there, let's work through this one. So P is the midpoint of FD. So then this one, so F to P is going to be half of F to D. Q is the midpoint of DE. So Q is D to Q is going to be half of D to E. Right, so use a vector method to prove that PQ, which is that one there, is parallel to FE. Right, okie dokie. So we're proving that this one is parallel to that one there, proving that those two, oops, daisy, proving that those two lines are parallel. And to prove that two lines are parallel in the world of vectors means that they are going to be multiples of each other. So if vector p to q is, if vector p to q is in fact parallel to f to e, it's going to be some multiple of f e. Does that make sense? It's going to be some multiple through vector rules, okay? Then what we need to do is we need to find p to q and we need to find f to e so we can see if it is in fact some multiple of. Does that make sense? So let's try and find p to q. So let's see what we can do here. So we want to go halfway up there to get to d, then another halfway down there to get to q. Right, so let's have a go at this one. So we can go half a, that one's a bit easy, just half up there, which is half of the full one, which is a. So we're going to do a half a plus a half of d to e. That's what we've got there. Okay, is equal to x lots of f to e. We'll deal with f to e later, let's deal with this bit first. Okay, and then we want to find out what d to e is. So to go from d to e, we could go straight down here. We don't know much about that track. We don't know much about that road. So let's go around instead. We could go from D to F, which is minus A, and then from F to E, which is B. Let's do that. So we've got half A plus a half of D to E, which is just minus A, and then plus B. Equals all of this stuff still over here. Okie dokie, then let's deal with this. So we've got half A plus minus a half a, poof, they're going to disappear, and then plus a half b. So we're going to left with a half b over here equals to x lots of f e. Okay, now it's time to find that. So we've got a half b over there, see I'm going to run out of space, equals then x lots f to e. Let's find that, f to e. Oh, that's easy, that's just b. Easy peasy. Would you look at that? X is indeed x is indeed a number, it's a half, right? So this p to q, should have an arrow there, my apologies. So this p to q is a multiple of f to e, it is a half of f to e. So, so the proof bit of it is, so pq is 1/2 of fe, so they are parallel, and that is all you need. Fun. There we are. That one actually wasn't too bad because I saw it and hadn't done it before, so hence me going on my spiel. But that one wasn't actually too bad. That I'd put at about a grade 7-ish. It's not quite grade 9, but I would put that at about a grade 7, 8-ish. Not easy, but definitely not the most difficult vector question you'll ever see. There we are. So I want to say that. Okay, question 22, nearly there. The diagram shows two shaded shapes, A and B. Shape A is formed by removing a sector of a circle with radius 3x minus 1 from a sector of the circle with radius 5x minus 1. Right. Shape B is a circle of diameter 2 minus 2x centimeters. Okay. The area of shape A is equal to the area of shape B. Find the value of x. You must show all your working. Okay, this sentence tells me all I need to know. Area of shape A equal to the area of shape B. I'm finding areas here, right? I need the area of A, area of B, make them equal, solve for x. So I'm going to swerve this for now, that looks complicated. I'm going to find the area of this guy, that's just a circle, easy breezy. So area of a circle is pi r squared. Actually, let me change that circle because they're both technically parts of circles, aren't they? I'm going to change that to b. So area of b is pi r squared. In this case, the radius is going to be a half of that, which is area, let me put this over here. Area of b is going to be pi times half of that, which is going to be 1 minus x. Right, it's half both the numbers, 1 minus 1x. Okay, so then squared. Perfect. So then AB is then going to be pi times, expand these brackets. So I'm going to have, so a trick to doing this, when it's both the same bracket, I'm going to show you two ways. But my little trick first is square the first number, 1, times together, minus x, double it, minus 2x, times square the last one, which is plus x squared. So that's that. Or you can do it the longer way, which is just write out the brackets, 1 minus x, 1 minus x, and then do FOIL. First, outside, inside, last. First, 1, outside, minus x, inside, minus x, outside, plus x squared. Simplify these to give 1 minus 2x plus x squared. All that there. So let's get rid of this for now. That's that. Hope that all made sense. Okay, so then that's as far as we can really go from there. We can times pi in, but that's going to make it worse. So let's leave it as is for now. Okay then, so even if you only get to this point, that's still, I'd imagine, at least 2 marks. So that's not bad, right? Even if you can't look, this looks complicated. This is why this part here could be why question 22, but not question 10, right? So let's have a go at this together then. So question area of A. Let's have a look. So we've got let's read it. Let's read all about it again because I've forgotten what it said about it. So shape A is formed by removing a sector of a circle with radius 3x minus 1 centimeters from a sector of a circle with radius 5x minus 1 centimeters. Okay then. So that's shape A, just a shaded bit, right? Am I gathering that right? Okay. So what we need to do for here then is work out the area of the full thing, take away the area of this little white bit, right? Not all that convenient. I wish I could just find the area of the shaded region, but this is the shape with no name, right? There's nothing we can really do about the shape. It doesn't particularly exist in any other context than this. We need to find the area of this bit and the area of all of it. The area of a sector is theta over 360 times pi r squared. So essentially just the area of a circle multiplied by the proportion of the circle that you've got. So the angle that you've got out of the total 360, which just kind of tells the equation how much of the circle that you have. So let's start filling this in. Let's do the white one first, then the full one, the big one. So for the white one, we've got 45 out of 360 times by pi times radius squared, which is 3x minus 1 squared. It's a gnarly question, isn't it? It's gnarly. Then let's deal with this. So 45 out of 360. That goes in a full number of times, doesn't it? That goes in, it does go into it 8 times, so it's going to be an 1/8 times pi times by this squared. A little trick familiar. We've got this one squared, which is 9x squared. Times them together, minus 3x, double it, minus 6x. Square this one, which is plus 1. Okie dokie, so that's all of that. Let's move on to then the area of, like, technically A, all of it. So area of all, guess it still works. So area of all of that is going to be the same equation, theta over 360 times pi r squared. So then we're going to figure out what, theta, easy peasy, that's just 45 still. So this is still just an 1/8. Let's put that in. It's the same angle, it's just a bigger part of the circle essentially, just bigger radius. So 1/8 times by pi times by radius squared. In this case, the radius is 3x minus 1 plus 2x, which is 5x minus 1. 5x minus 1 squared. Let's deal with that. So we've got an 1/8 times pi times, do my little trick, 25x squared minus 10x plus 1. It's looking gnarly, it's looking not good. Ugh. Right, so then I'm going to run out of space here, aren't I? Good lord. Right, so let's then deal with these. So that's the total, that is the little bit. So let's then kind of take these away from each other. So we have got the full bit. I'm going to write up here. I'm going to change colour. Different part of the question, different colour. Let's put this up here so we can see. Right. So I'm going to do an 1/8. Take 1/8 pi of all of that. 25x squared minus 10x plus 1. Take away an 1/8 pi of all that, 9x squared minus 6x plus 1. Okay, and that is then equal to this. Ugh. So that is then equal. I'm going to definitely run out of space here. This is awful, isn't it? That's going to then equal all of this here. So we've got pi lots of 1 minus 2x plus x squared being equal to all of this here. What I'm going to do here is I'm going to cancel out these pi's. I know they're going to be equal to each other, and they've got pi's everywhere. So divide through by pi, gone, gone, gone. Can't bother to deal with all that. And then I'm going to, because the tricky thing is none of these divide by 8. It should be rather convenient, wouldn't it? But none of them divide by 8, which is kind of annoying. So what I'm going to do is factor out 8 instead, because they both have 8 in it. Let's just pull 8 out, get it to the side, and then we can deal with these, make it a bit smaller. So let's see, 25 minus 9, that makes 16x squared. And then I've got minus 10 minus minus 6, which is then minus 4x. Then I've got 1 minus 1, which is just nada, nothing. Okay, let me double check that because I am prone to making mistakes, and this is a very mistake. Like mistakes are going to cling to this question, aren't they? You're going to make so many. 25x squared, take away 9, that's going to be 26. Minus 10 minus 6, that's 10 minus 10 plus 6, which is minus 4, and then 1 minus 1. Okay, so then I have got 1 minus 2x plus x squared equaling an eighth of 16. My face is there. So getting used to what you can and can't see. I'm going to shuffle it over a little bit, put it down here. So then I've got 1 minus 2x plus x squared equals an eighth of 16x squared minus 4x. This eighth, getting on my way, getting on my nerves, getting in my way, so I'm going to times it all through by 8. Get rid of that eighth. So then I'm going to get 8 minus 16x plus 8x squared equaling 16x squared minus, you can't see that, minus 4x. There we are. Then what I'm going to do is, I'm going to have to get rid of some of this working. I don't really want to, but my apologies. I'm going to have to get rid of some of it to make some space. This question is outrageously long. Okay, then what I'm going to do is make this equal to 0, because this is a quadratic type thing, right? So I'm going to factorize this, put it in double brackets at some point. So I'm going to have to make it equal to 0. So I'm going to take all this over there to keep this x squared a lot positive. So what I'm going to do from here, I'm going to write down here, is take away 8 from 16, so we get 8x squared. Then we're going to get minus 4x plus 16x, which is plus 12x, and then minus 8 equals 0. And then I can simplify this a little bit, divide it all by 4 to get 2x squared plus 3x minus 2 equals 0. Then it's time to factorize this. So then I'm going to get, so I'm going to times to get minus 4 and add to make 3. So that is 1 and 4. And then I'm going to do plus 4 minus 1 to then get 2x minus 1, 2x plus 4. Simplify this bracket to then make 2x minus 1 x plus 2, and then expand it out. Well, not expand it out, but get your values. X equals, add 1, divide by 2, a half, x equals minus 2. But you can't have x equals minus 2, because then that will give this a negative length. That's illegal. So we've then got equals. So then that must mean that x is a half. Oh, would you believe it? All that work for 5 marks. Horrible. Oh, you can't even see some of it. My apologies. Hang on, let me just shuffle it down a little bit. Let me see if I can, so you can see it a little bit. There we go. That's all I've done. Just this bit down here. So, all that work for 5 marks. Have we followed it? Does it make sense? It's all, essentially, it's just a bit load of it's just a lot, really. It's not particularly difficult maths. It's just a lot all at once, if that makes sense. Like, if this question was simpler, if these use numbers and not algebra, people will be able to do it much easier. It's just the fact that there's so much algebra everywhere. Look at all this. Look at all this mess on my page currently. So that's why it's so difficult. But hopefully we both followed along with that one. That one was tough. Okay then, question 23, last one on the paper, nearly there guys. So there are 4 types of cards in a game. Each card has a black circle or a white circle or a black triangle or a white triangle. So the number of cards with a black shape, so the number of cards with a white shape is 3 to 5. Number of cards with a circle, so number of cards with a triangle is 2 to 7. Express the total number of cards with a black shape as a fraction of the total number of cards with a triangle. Right, okie dokie then. So let's have a little think about this. Let me change my colour pen back from the yellow. I was away from the yellow I had last time. So, gosh, gonna test me this one. Let's have a little think. So, number of cards with a black shape to number of cards with a white shape, that's 3 to 5. So we've got 8 parts in this problem, right? So we've got 8 parts to this first bit. So we've got 3 out of 8, that's cards with a black shape. 2, 5 out of 8, that's cards with a white shape, right? Then we've got number of cards with a circle to number of cards with a triangle is 2 to 7. So same thing here, just instead we've got 9 parts here. So we've got 9 parts for the second bit. So then I've got 2 knights, that's cards with a circle, to 7 knights, that's cards with a triangle. Okay. Grand. So then we want to express the total number of cards with a black shape as a fraction of the total number of cards with a triangle. So now we've got these fractions. We've got 3 8s, we've got 7 9s. We want to know it as a fraction of the total number of cards with a triangle. So number of cards with black shape, that's 3 8s. As a fraction, but with the triangles, that's 7 9s. It defines things as a fraction of something else. Divide them. All you need to do, divide them. Then we're going to divide these. So we're going to do keep flip change, which is 3 8ths times 9 7ths, which is 3 times 9, which is 27, over 8 times 7, 56. And would you believe it? That is it. So much easier than the last question, isn't it? How strange. I don't understand some of the ordering sometimes. That I can never comprehend sometimes. But that is all there is to it. So that's the paper. Thank you all so much for watching. If you have enjoyed, I will be making more of these, so please leave a like and subscribe so YouTube can tell you when I've made more. And let me know how you felt about the paper. Feel free to leave a comment. I'd love to know how people felt about it. I didn't think it was too bad. It's not definitely an easy paper by any stretch, but I thought it was kind of like a mid-tier paper. Did you guys agree? Let me know. Again, thank you so much for watching, and I'll see you in the next one. Bye!